As we're talking about SpringMass system, it is important to define the acceleration, velocity, and displacement within the SpringMass system. We saw before a spring attached to a certain weight or a box. When you apply a certain force to squeeze that box towards the spring or to pull it away from it, the box will start to swing back and forth in an oscillatory motion or a harmonic motion. That motion giving the box velocity and acceleration. If you want to define the forces applied on that box or on the spring, depending on your perspective, you can use the Newton's second law, the F net equals mass by acceleration, or you can use Hooke's law, where you can say the force, return force in this case, equals minus k by x, which is the displacement of that spring. Now both equations can be referring to the restoring force, so you can equate them. You have F net equals F return. F net is represented as mass by acceleration equals minus kx. In this case, the acceleration a would equal minus kx over the mass m. So a in this case is the acceleration in meters per second squared, and the k is the spring constant in newtons per meter, and the x is the displacement in meters. The author is mentioning that the object does not have to be moving to experience acceleration. What does that mean? When you pull the box connected to the spring, you pull it and you let it go, and the box will go back and forth. At some point, let's say at the point where the box is going all the way to the right and he need to be pulled back to the spring, he will be momentarily with a velocity of 0, but the box is, we know that for a matter of fact that the box will be eventually pulled and gain the speed again, and the speed wouldn't be constant, so the box will be gaining acceleration. So that's why they said an object does not have to be moving to experience acceleration. That means momentarily. But personally, I don't buy this sentence, and I think this information is misleading, because the box in general need to be moving in a varying speed to be able to give it a certain acceleration. I don't care about momentarily actions by this time. As we mentioned, the box is going to the right positive and to the left negative. If you draw the acceleration versus displacement, you can see here the acceleration as displacement increase, the acceleration is decreasing. As displacement is decreasing, the acceleration is increasing. Which means when you pull this box backward and it is attached to the spring and you let it go, the box will start to swing back and forth. The less the distance or the displacement of the spring, the higher the box will be oscillating back and forth, which means the higher the acceleration. Now there is a relation between velocity and acceleration for the SpringMass system. The acceleration of a simple harmonic oscillator continually changing, and the velocity is changing as well. So the maximum acceleration occurs when the oscillator is at its maximum displacement. So we think at the maximum displacement, the velocity will be at the max as well, similar to the acceleration, but the reality is the acceleration would be at the maximum displacement at its greatest magnitude at the extreme of motion, but the oscillator has stopped for a few seconds in this position, which means the velocity at that moment is 0. And that's the case as well for a ball that you throw it vertically. When you throw it up, it will keep increasing the speed. It will start with a high speed. The speed will keep decreasing until it reaches the top point where the force of gravity is pulling it downwards more than the force that pulled it upwards. So in this case, the ball will start to accelerate back until it reaches your hand at the same speed as it lifted. But as I mentioned, the sentence that it doesn't necessarily need the object to be moving to be able to have acceleration is a misleading sentence. It could be right in a certain way with a certain circumstances where you're talking about an exact moment where the object is changing direction from up to down or from right to left. But that's really a questionable sentence. I wouldn't take it in consideration. Now, if we draw the velocity versus displacement, we can see here we are at position A, then position B, then position C. As we're moving towards C, the displacement was in the negative, going to 0 to the positive. We can see here the velocity started with 0 and gradually increased to the maximum point, and at the maximum displacement the velocity was 0, and as well as the maximum negative displacement the velocity was 0. The velocity was the max along the way between the maximum negative and the maximum positive, which is at the point where the displacement was 0. We're talking here about instantaneous velocity, and when we talked earlier, we talked about instantaneous acceleration, just to avoid any confusion in your understanding. But we go back to the simple rules. You have a box, you pull it to the right. Now the spring force needs to pull it back, or the return force needs to pull the box back to be able to return the balance point for the spring. The box will be swinging back and forth. He is gaining acceleration. The smaller the swinging, or the more repetitive the swinging, or the smaller the displacement for the spring, the higher the acceleration. And that doesn't apply in any means for the velocity. Velocity at the maximum displacement is 0. Acceleration is potentially the highest at the extremes, where it is at the top the most, or at the maximum displacement and at the minimum displacement.